And this used to be called the factor label method. Used to be called the factor label method. This is how physical scientists, so chemists and physicists, and engineers do math. And it really has one rule. After every step, a unit must cancel out. After every step, a unit must cancel out. Write that down. Get on it. Okay. At first, I'm going to start with some conversions here, and you're going to say, whoa, I don't need dimensional analysis to do this, you crazy person. I could just do it. Okay, well, we got to start somewhere. And we're going to start with some units that you guys already know. And then hopefully you'll see that within the next 30 minutes, you're like, oh my God, I couldn't possibly have done that problem without dimensional analysis. So I need you to hang in there with me. Okay. And I'm going to walk you through these problems. Let's say I want to convert 45 feet into inches. How do we do this using dimensional analysis? I know, right? Multiply by 12, right? Yeah. And again, with a lot of these problems, I couldn't care less about the problem. It is the methodology, right? Okay, and you'll see this on Thursday when we do stoichiometry. Okay, we set it all up with dimensional analysis. So, like myself as a chemist, I don't care if you convert between feet and inches, but we got to learn this system, and we're going to learn the system using, conversions between lengths and volumes and masses and all that stuff, right? So I need you to buy into the system, or Thursday it is going to be like not good, right? Here's how we do this. Whenever we do dimensional analysis, the first thing we do is we take the measurement we're given and we put it over 1. And we put the unit. And in fact, that unit is the most important part. So that foot is the most important part. So if we're doing 45 feet, we're putting it over 1. And now what we need to do is use a set of conversion factors to get from one unit to the other. Now this one is really easy because it's a one-step problem. Okay, we only need one conversion factor here. 1 foot is 12 inches. And the goal of dimensional analysis is this. Okay, we are going to determine where the 1 foot goes and where the 12 inches goes based on the fact that after each step we have to get a unit to cancel out. So I need that feet to cancel out, okay? And units cancel out diagonally, okay? Now eventually we'll get units that are in the denominator. They'll cancel out like that. But right now, that foot's here. So the 1 foot has to go here so that that can cancel out. And then the 12 inches has to go here. Now, if the number is in the numerator, we're going to multiply. If that 12 had been in the denominator, we would have divided. So we're going to do 45 times 12. So 45 times 12. And this is one of the few times where your calculator did not lie to you. 540. Why didn't it lie to you? This measurement had 2 sig figs. These conversion factors are definitions. They do not limit your sig figs. So the number of sig figs in your final answer is how many sig figs you start with in your conversions. So since I started with 2 sig figs, I need to end with 2 sig figs. That's a trailing zero without a decimal point. 45 feet is the same as 540 inches. Okay? I know. It's trust me. Give me a couple minutes. You won't be doing problems. You were like, I couldn't have done that before. No. Let's go the other way, maybe. Let's do yeah. let's do this. How about 87,500 feet? I want to know how many yards is that. Obviously, we want to divide by 3, but I want to show it using dimensional analysis. So what are we going to do? Okay, first step, take the measurement you're given, 87,500 feet, put it over 1. And now we need a conversion factor to go between the two. So the conversion factor we're going to use is 1 foot. 1 foot. 3 feet is equal to 1 yard. Okay. I need feet to cancel out. So the 3 feet goes on the bottom and the 1 yard goes on the top. So this time we're going to divide. So because that 3 is in the denominator, we're going to hit divide. So we're going to do 87,500 divided by 3. Now, your calculator would tell you the answer is 29,166.7. Okay? How many sig figs? My original measurement had 3 sig figs. Again, that's a conversion factor. That's a definition. That doesn't limit your sig figs. This is where your sig figs come from. 3 sig figs. We need to end with 3 sig figs. That rounds up. The answer is 29,200 yards. So 87,500 feet is 29,200 yards. How are we feeling so far? Has everybody done dimensional? I remember distinctly doing dimensional analysis 6th grade. Mr. Sainer's 6th grade class, I remember the first time ever doing dimensional analysis. We were converting like years to minutes or something. And I remember setting it up, and I remember it just sticks out in my mind. I don't remember much else, but I remember 6th grade. We'll do a time conversion here in a moment. All right, let's get crazy. Do a multi-stepper. It's gonna be good. Good year. I don't watch the NFL. I would love college football. Big Michigan Wolverines fans. Last year was a great year. Probably never win the national championship again. But anyway, back in the day, good year for a running back is if they rushed for 2,000 yards. I'm going to do 2,000 with a decimal point. And I want to know, okay, well, they're making $8 million a year to go 2,000 yards. They're making $8 million to go how many miles? Okay. I want to solve this using dimensional analysis. Now, the first thing we do, and in fact, this is worth a point. Like on a test, I will give you a point. I call it the pity point. Okay. You take what you're given, 2,000 yards, and you put it over 1. And now we're going to need multiple conversions. I do not know how many yards are in a mile. I have no idea. But what I do know is I'm going to give you these 2 conversion factors. I know that 1 yard is 3 feet. And I know that 1 mile is 5,280 feet. And this is going to be a 2-step dimensional analysis problem. And I encourage you to not pick your calculator up till the very end. So we want to get from 1 unit we want to get from yards to miles, and then we're going to pick up our calculator. So here's how this is going to work. Dimensional analysis. Any step in a conversion is valid as long as after each step a unit cancels out. So I need yards to cancel out. So I'm going to use this conversion. The 1 yard is going to go on the bottom, and the 3 feet is going to go on the top. And what I just did here is I went from yards to feet. And now I want to go from feet to miles, and we have a conversion for that. 1 mile is 5,280 feet. So the 5,280 feet is going to go on the bottom because I need feet to cancel out, and the 1 mile goes on the top. And now I have achieved my objective. I went from yards to miles. And now I'm going to grab my calculator. And when I punch this in, if the number is in the numerator, I hit multiply. And if it's in the denominator, I hit divide. So if I punch this in, I would do 2,000 times 3 divided by 5280. I started with 4 sig figs. I need to end with 4 sig figs. That's 1.136 miles. So if you're an NFL running back, you're getting $8 million to maybe go 1.136 miles for the whole season. Now that's a hard fought 1.136 miles. Okay, but yeah, and obviously, I mean, I want to be a running back. Those guys, they end up not really ever making too much money because they get injured and tossed to the curb before they get a second big contract. But anyway, yeah, dimensional analysis. Got to get units to cancel out each time. Now I know what you're saying. You say, wait a minute, Nate. I didn't know that 1 mile had 5,280 feet. Maybe you did. Don't worry. On the test, you're going to be given a conversion factor sheet, which is going to look like this. Let's take a look at that. So I've got it up there on D2L, but I also have it somewhere. Spaghetti-O. Oh, here it is. Here's the periodic table. Go to the conversion factor sheet. So the conversion factor sheet is organized based on length, volume, mass, and I even give you the temperature conversions here. You don't have to memorize those. And then here are the metric prefixes, which we'll get to in a moment. So I don't know how far I can zoom out here and have your phone cameras pick up on this stuff, but I'll do that. If you're not watching on your phone, if you want to take a picture of that right now, maybe not a bad idea if you don't have access to a printer, because that's going to have the conversion factors that we're going to use here in a second. And in fact, we're going to do a time conversion here where you don't even, hopefully, I'm assuming you guys have the time conversions memorized. Okay, I'll give you another second if you want to snap a picture of that. Awesome. All right, let's do this thing. Here we go. Let's do a time conversion because you don't need the conversion sheet to do that. Anybody have a birthday recently? They want to tell me how old they are, or anybody got a birthday coming up? My mother's got a birthday coming up. I guess I could use hers. Hers is on Saturday. She's the 25th. She was born in 59, and it's 2024. So she's going to be, what is that, 65? Oh my God. That's old. Anyway, let's calculate how many seconds my mother has been alive come Saturday on May 25th. I believe she was born at 6 o'clock in the afternoon. So anyway, I want to convert 65 years into seconds. So when my mother at 6 o'clock p.m. on Saturday, when my mother turns 65, how many seconds has she been sucking oxygen on this beautiful planet? Let's do it. First thing you're going to do, you're going to take 65 years. You're going to put that over 1. Now, if you know how many seconds are in a year, well, that makes you weird because I don't even know that. Okay, now if you're a fan of the musical Rent, there's 525,600 minutes a year. We're not going to use that, though. Let's pretend we don't know that. What are we going to do here? Well, I got to get from years to seconds. So I got to start using some facts about time that I know and do some dimensional analysis. So the first fact that gets me closer to seconds is I know how many days are in a year. Now, we're going to be super precise here because we're doing chemistry. And that's what chemistry is all about. We got a bad reputation, us chemists, for being super picky. So there are not 365 days in a year. Because of leap years, there's 365.25 days in a year. So the first conversion factor we're going to use is that 1 year is 365.25 days. So we're going to put that 1 year on the bottom, and we're going to put 365.25 days on the top. And now, what do we know about days? Well, we know that one day is 24 hours. And now what do we know about hours? Well, we know that 1 hour is 60 minutes. And then what do we know about minutes? We know that 1 minute is 60 seconds. And I need to, in order for you to get full credit on a conversion problem, when we get to stoichiometry on Thursday, I need to be able to take my pen and I need to be able to go and cancel out the units all the way across. If I can't do that, you're missing something, right? Okay, so now let's do it. All these numbers are in the numerator. We're multiplying across. So 65 times 365.25 times 24 times 60 times 60. Oh my goodness, what a number. My mom is old. 3, don't tell her I said that. 2, 0, 5, 1, 2, 4, 4, 0, 0, 0 seconds. Is that 2 billion? Oh my God. Okay, now, technically, 2 sig figs. So we should round that up. So that would be 2.1 billion or 2,100,000,000 seconds. Or 2.1, and they got 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.1 times 10 to the 9th seconds. So this Saturday, Mom will have been on this planet for about 2.1 billion seconds. You know, crazy. So again, why dimensional analysis? Dimensional analysis takes a problem, there's multi-steps, and maybe a big problem, and it really breaks it down into a bunch of simpler steps and gets everything to cancel out. So we've done length, we've done time. Let's do a mass conversion here. Then we got to get into the metric system. We're going to get there. We're doing all right. We're doing good. We're going to end before 9:50. That's the name of the game. Do a mass conversion. Let's go between the United States customary system and the metric system. So let's say, I don't know if you noticed this, but my doctor is now weighing me in kilograms. I go into the doctors and they do the weight in the kilograms, and I always do a quick calculation in my mind, and I try, what is that in pounds? Because I know what my bathroom scale says, which is in pounds. Okay, but the medical system has moved to kilograms now, which is pretty cool. It's more scientific, right? So I don't know. Maybe you go to the doctor and the doctor says that you're weighing in at 68 kilograms. And you want to say, well, what is that in pounds, man? Huh? And here's the conversion, 1 kilogram. And it's on that sheet, if you took a picture of it, is 2.2046 pounds. 2.20, let's check. It's 9:04 at night, so 2.2046. Look at that. Someday you too will have useless conversion factors memorized at the tip of your tongue. Anyway, here we go. 68 kilograms over 1. Dimensional analysis takes the guessing out of, do I multiply by 2.2046 or do I divide by 2.2046? And it takes the guessing out of it because you got to get the units to cancel out. So it tells it for you. So I need kilograms to go away, 1 kilogram on the bottom. 2.2046 pounds on the top. We're multiplying. So 68 kilograms, 68 times 2.2046. Your calculator says 149.9128 pounds. 2 sig figs, that round, so 150, no decimal point, pounds. 150 pounds. 68 kilograms, 150 pounds. So we did a mass conversion. Awesome. Now we need to talk about that pesky metric system. Here's our metrics prefixes. I want you to know kilo to million. Okay. When you were taught how to do metric conversions in middle school and high school, they probably had you move the decimal point. I am not a huge fan of that. Let me tell you why. People move the decimal point the wrong ways. Yeah, like they'll move it, like they're supposed to move it 3 places to the left. They move it 3 places to the right. Now they're off by 10 to the sixth. It's not great. So, sorry, losing my voice. Here's how I like to do it. I like to do metric conversions. Okay. I do metric conversions with dimensional analysis. Now you'll notice I did not put negative exponents on here. That's because the way I do my conversion factors, I don't like to think of a centimeter as 0.001 meters. I like to think that there's 100 centimeters in a meter. I like to always keep things positive instead of going to decimals. So that's why I do not have the negative exponents down here. You also notice that on that sheet, I don't have the negative exponents. I like to think of it as like an absolute, like this is, I like to think of it as like this is 10 away, and this is 10 away, and this is 100 away, and this is 100 away. I don't like to do the negative. I don't like to do the negative, powers here. So let me show you a conversion. Let's say I want to go from 45 meters to kilometers. The way I would set it up is like this. I would do 45 meters over 1. And then the beautiful thing about the metric system is you can do any metric to metric conversion in one step. So meter is my base, and I'm trying to get to kilometer. Now, when I do a metric to metric conversion, the bigger unit is going to get a 1 in my conversion factor. So I'm building my own conversion factor. So what I would say is I would say this, well, kilo is bigger than meter, right? So 1 kilometer is 1,000 or 10 to the third meters, 1,000 or 10 to the third. So meter has to go on the bottom, 1,000 meters on the bottom, 1 kilometer on top. I started with 2 sig figs. 45 divided by 1,000 is 0.045 kilometers. So notice how we can still set this up and use dimensional analysis, even though it's in the metric system. In the metric system, all you need to know is a couple things, and you can build all of the conversion factors. Let's try another one. $18 meters. How many centimeters is that? I'm going to take the 18 meters. I'm going to put it over 1. And meters my base. I'm going to build my conversion factor. Now, the bigger metric unit gets a 1 because I like to think of these as big numbers, right? Always positive numbers. So meter is bigger than centimeter. So 1 meter is, that's a difference of 10 to the second, which is 100. 1 meter is 100 centimeters. So 1 meter on the bottom, 100 centimeters on top. We're going to do 18 times 100. That's 1,800 centimeters. 2 sig figs, 2 sig figs, no decimal point. Not bad. This wasn't that bad because both of these involve the base unit. But what if I'm trying to go from, something above the base to something below the base? Okay, for example, This kind of problem sometimes trips people up. Let's say you do something stupid like sign up to run a 5K. I'm not a runner. My wife does 5Ks and stuff. I was like, what are you doing, man? Running to me is just not, it's not enjoyable. I don't know. Anyway, maybe you sign up to run a 5K. Afterwards, you're like all delirious. And before you pass out, you wonder, how many centimeters did I just travel? Here's how I would do that. This is a metric to metric conversion. And at the end of the day, you can do any metric to metric conversion in one step if you know what you're doing. So what I would do is I would do 5.0 kilometers over 1. And I would build my conversion here. So I would say, okay, 1 kilometer is how many centimeters? Well, it is 10 to the third to the base, and then another 10 to the second to centi. So they are 10 to the fifth apart. They are 10 to the fifth centimeters, or 100,000 centimeters in a kilometer. Now, here's the absolutely awesome thing about the metric system. It's going to blow your minds. Okay, 1 kilometer on the bottom, 10 to the fifth centimeters on top. You don't even need a calculator, right? 5.0 times 10 to the fifth. That's 5.0 times 10 to the fifth. It's already in scientific notation for you. You are ready to go. If you run a 5K, you just went 500,000 centimeters, right? So you can even do conversions from above the base to below the base, right? It's not that bad. Okay. Let me give you one more. Okay, we'll do an English to metric and do another metric, and then I'll talk about units in the denominator and squared and cubed units, and we'll get you out of here. So how about maybe you do something really stupid, and you decide to run a marathon, right? What were you thinking, right? Okay, and that's what, 26.2 miles. Ugh. And afterwards, they're hauling you off in the ambulance. And you think to yourself, I wonder how many centimeters I just went. Now, if you have that conversion sheet up, we got a lot of ways to do this, okay? Let's talk about some of the ways to do it. There are often many correct ways to do a problem. So if we look in the length box, and that's where we need to focus because we're going from miles to centimeters, that's length. We need to be able to get out of the United States customary system and into the metric system. Now, the fastest way to do this problem would be the way we're going to do it here in a moment. You can go from miles to kilometers using this conversion factor right here. And again, you're going to have this on the test. You don't have to memorize it. 1 mile is 1.609 kilometers. But maybe you didn't see that. You could do a couple other things. You could take those miles to yards, and then you could go to meters. You could take the miles to feet to inches, and then go from inches to centimeters, right? That one wouldn't be that bad. Okay, and maybe we could even show that one. That one would be 3 steps, and you don't even have to mess around with the metric system, which scares people. So let's try and do this problem with this conversion right here, where 1 mile is 1.609 kilometers. So we're going to take the 26.2 miles, we're going to put it over 1. And the whole point of dimensional analysis is to get stuff to cancel out. So the 1 mile goes on the bottom, and the 1.609 kilometers goes on the top. And now we're going to try to do what we just did. We're going to go from kilometers to centimeters. So 1 kilometer is 10 to the 5th centimeters. Starting with 3 sig figs should end with it. If you have your calculator, grab it. 26.2 times 1.609 times 10 to the 5th. And we should get 4,215,580. 3 sig figs, that's right there. 4,220,000 centimeters. And that's our final answer there. So if you run a marathon, you go 26.2 miles, you're going 4.22 million centimeters. Now, the other way we could have done this, we could have done 26.2 miles over 1. We could have gone 1 mile is 5,280 feet. We could do 1 foot is 12 inches. And then we could have used that conversion factor that's on there that says 1 inch is 2.54 centimeters. And that would be totally fine. We should get the exact same answer. Now, maybe a little off with rounding. 26.2 times 5280 times 12 times 2.54. And we get like the same answer almost, right? 4.22 million centimeters. Doesn't matter how you do it. Awesome. Awesome. Okay. 2 more things to deal with here. What do you do when units are in the denominator? For example, oh man, let's do a gas mileage one, right? So, here in the United States, we measure our mile or gas mileage in miles per gallon. But like in Europe, I would imagine they do it in kilometers per liter. So maybe you got a friend in like Spain or something, right? And you call in to brag about your new, Toyota RAV4 hybrid that's getting 48 miles per gallon. And they're going to say, well, what is that in kilometers per liter? And let's do it. So maybe you're getting 45 miles per gallon, and we want to convert that to kilometers per liter. This is where we're going to need that unit conversion sheet. And since you don't have a physical copy, maybe I'll write down some conversions for you. 1 gallon is 3.7854 liters, right? I know. That's how sad my life is. And 1 mile that I have.
You mean what he said? It's like, that's how sad my life is.
Yeah, it's pretty sad. And 1 mile is 1.609 kilometers. I figure when I lose my mind, get locked up in a nursing home or something, I'm like 80. I'll just be like rattling these off or like writing it on the walls, or whatever. It's random conversion factors. Anyway, so let's do this. So here's how this problem is a little different. We got a unit in the numerator we're trying to change, and we got a unit in the denominator we're trying to change. And the way that I usually recommend this is we ignore the one in the denominator first, and then do the one in the numerator. So we just do the one in the numerator first, and then we're going to go and do the one in the denominator, talk about how that cancels out. So the key to getting this problem right when you have a unit in the denominator is putting that unit in the denominator. So what have we been doing? Well, we've been taking our measurement and we've been putting it over 1. But this time it's not over 1, it's over 1 gallon. So you're going to put that 1 gallon down there. And I'm telling you, if you write this down like this, your chances of getting it right are going to be pretty good. Okay, we are going to ignore that at first. And we are going to pretend that we're just trying to go from miles to kilometers. So we need miles to cancel out. We're going to use this guy, 1 mile in the denominator, the 1.609 kilometers on the top. So now I've taken care of the numerator. Now I have to look at this. Here's how this works. With dimensional analysis, units cancel out diagonally. This gallons is in the denominator. So it's going to cancel out like this. So the 1 gallon has to go up here. And the 3.7854 liters has to go there because that is how gallons cancel out. And I'll be left with what I wanted, kilometers per liter. So let's punch it in. 2 sig figs is what we started with. 2 sig figs is what we're going to end with. 45 times 1.609 divided by 3.7854. And that would be 19 kilometers per liter. Then you call your buddy up and you say, I'm getting 19 kilometers per liter, man. And they'll be like, whoa, that's great. How we do that. Last thing I'm going to cover is what do you do when units are squared? or cubed? Like, how do you deal with that? I'm going to give you two strategies on how to deal with that. Any questions on the unit and the denominator thing? They just cancel out like that. Not that bad. Yeah. No, man. Let's do an area, like in inches or something. Let's say you have an area, and it's 180 with a decimal point inches squared. And I want to convert that to feet squared. So I want to go from square inches to square feet. First strategy, this is how I always did it till my friend who teaches physics at Township, his name is Anton, he's from Sweden. So he showed me a different way. I still do it my way, but I show his way because I found a lot of students that are first starting out like his way. So let me show you my way first, all right? So I would do 180 decimal point inches squared, put it over 1. I would ignore the squared for a second, and let's just pretend we're trying to go from inches to feet. So I would obviously 1 foot is 12 inches. Y'all have that memorized, I'm sure. So we're going to do the 12 inches on the bottom and the 1 foot on the top. But now I need this to be squared. So we're going to square the conversion factor. What does that look like? Well, that's 1 squared, that's 1. And then that becomes feet squared. And then 12 squared is 144. Too late, Oh my gosh, I can't hit the right button. So that's going to become 144 inches squared. So now it's going to be 180 divided by 180 divided by 144. That's 1.25 square feet. Now here's what my friend Anton would teach you how to do this. Anton would say 180 decimal point inches over 1. And inches squared, so sorry, over 1. My friend Anton would say, all right, well, since this is squared, you just have to use that conversion factor twice. If it was cubed, you'd use it 3 times. So Anton says, all right, well, we just do this twice. So 1 foot 12 inches, and then times again 1 foot 12 inches. And when you do that, that becomes feet squared. That's inches squared. The inches squared cancel out, and you get the same answer. If it was cubed, you would just do it one more time.